Let's try that again. So experiment1.txt is there on the left, which means I can do a equals import data experiment1.txt. Now, it's probably going to freak out because I didn't give it all the same arguments, but let's see. If I look in A, there's two fields in A. So A is a structure with two different fields. So on the left, whenever you create a variable, you always see it appear on the left. So here we've created A. Here it is. You can double click to look what's in it. And there's two things in it. Now, whenever you want to access this part of the structure, we have to refer to it with a.data. Whenever we want to access this part of the structure, we have to refer to it with a.textData. If we look what's in the text data structure, it's all the fields that MATLAB recognized as containing text as opposed to numbers. And if we look at the data section, it's just the numbers from this document. So when you do import data with MATLAB, it automatically separates the data into string data and data, number data. And so we have to refer to one part of it with .data and the other part of it with .textData. Okay, so this is what we finished with last time. We managed to, and hopefully most people managed to get it working, we managed to run this print gene expression function to load data from a file and figure out what genes were in the file, and then run our print gene expression function to only print those that were over some kind of threshold. So the output from running that looks something like this. The reason it looks like this is because in our print gene expression function, you'll notice we have two functions going on now. We have print gene expression from file, and we have print gene expression. The print gene expression from file function is calling the print gene expression function. Remember, we coded the print gene expression function separately before, and that was the one that printed genes over a certain value or genes of interest. And we're calling that on the data in our file. So it will go through every line of the file, and it'll run the print gene expression for those for those genes in the file, and print those that are over a certain threshold. And so the output from running that looks something like this on the left. And what that is the gene name and the expression value for every gene in the file. Now, it might look a little ugly. You might have this scientific notation where everything is given to crazy levels of detail. And one way to tidy that up is to adapt the print statement in our print gene expression function to give a different level of detail in our responses, so to give a different number of decimal places in the numbers that it prints. So what we had here was, remember, we're in the inner function now, we're in print gene expression. We went through every line of the results, so for I equals 1 to the length of the results, if the result was over the threshold, we printed the gene was some string and the expression was some number. Now this didn't look like this before, so we've changed the type of number we're using. Remember, we've been using %d for some numbers, and that's been printing integers. But now if we want to use floats, we can specify the number of decimal place information we give. So instead of writing %d here, if we write %f, it knows that it's going to be a number with decimal place information. If you do %.2f, it's going to do it with 2 decimal places. So this is really useful for easily changing the degree of precision in your outputs. So if you wanted to print them with only 2 decimal places of information, you would do it like this, %.2f, and then the rest of the fprintf statement stays the same. It's still going to be a gene name and then a gene value that we're substituting in. So if you make that small change to your inner function, you should see that everything goes from looking like this, or perhaps these would be whole numbers in your example, to looking like this, where everything is specified to 2 decimal places. and then give the number a change, try 3 and 4, and you'll see that it adapts the number of decimal places that the output is printed to. So there's a lot of tricks we can do with this fprintf substitution, but specifying the numbers of decimal places of the output is one that we use quite a lot. Everyone see how that changes the sort of output detail? Okay, cool. So we're going to come across, we're going to talk about writing to files now. So we've been reading from a file. We've managed to load some data from a text file. We've loaded an image and we've loaded a data file. Now we're going to figure out how to write to files. And it's actually fairly simple. There's a few ways of doing it. This is the sort of standard, rigorous, old-fashioned way of doing it. So there's 3 main commands you're going to need. One is fopen, which will open the file. And this is the only time you're going to refer to the file with the file name. So when I say refer to the file with the file name, I mean that its location on the disk might be c:/mydocuments/myfile.txt. This is the only time you'll give it that full location on the disk that you want to, where you want to actually save the file. So when you do fopen and you give a file location here in the file name field, it will then create a variable on the left of the equals sign that represents that file. So that there'll be a file identifier variable created. And that variable is what we then use from now on to refer to the file. You don't refer to the file as c:/mydocuments/myfile.txt. You refer to the file with the file identifier variable that you just created. So you'll notice there's an extra variable here. There's a W. That means that we want write permissions to be able to write to the file. If we are writing to a file that contains some data that we don't want to overwrite, I guess that's pretty redundant, but if you only want to read from a file, you can give it R permissions here to only have read permissions, and there's plenty of others like only being able to append to a file and not erase any of the existing data. But because we're talking about writing output files here, write permissions are what we're going to need, so we're going to need that W there. Then to write to a file, it's actually code that we're very familiar with because we've been using fprintf a lot to print output and to substitute things in, and we've even seen things to various decimal places and how to do new lines, etc. We're going to use all that knowledge when we're printing to files because we use exactly the same function, and the only difference is that we add this file identifier variable at the start of our print statement. So if we don't have a file identifier there, we know that it prints to the screen. It prints the output in the command line. If we do have a file identifier there, it's actually going to print to the file. So it's going to put the text in the file for you. And then finally, when you finish, you're going to want to do fclose. And this shouldn't say FID here. This should say file identifier just to be consistent. So you're going to close the file identifier that you've already opened to make sure that it's closed, that MATLAB has done editing it, that it's available for other programs. It's a good habit to get into, to close files after you've finished editing them. If you don't, sometimes you might not be able to open them. It might say that they're locked by MATLAB. And in rare cases, if MATLAB crashes or something, the file can become inaccessible and corrupt. It's a bit like ejecting a USB drive. You know how you have to click eject before you pull it out, and sometimes you don't, and it's okay. If you don't close a file, it's probably going to be fine, but it's a good habit to get into because occasionally you'll just lose everything.
What's the append?
Append? Append is A, I believe. So it's W for read, R for write, A for append. Okay, so what we can actually do is adapt the function we wrote so that rather than printing the gene expression to the screen, it prints the gene information to a file. So that we take our input file, we load it in, we check what's over a threshold and what isn't, and then we print those that are over a threshold to a file. So that's most of what computational biology is going to come down to in the end. It's loading some input data from a large file, doing something for the entire file, and saving some processed output to another file. So we're going to make changes in both of our files. The first thing we're going to do is add an extra input argument to our print gene expression from file function. So you'll notice there's an output file name variable been added here. We already had input file name, gene of interest, and threshold. Now we have an output file name as well. You can put that wherever you want in the input, in the argument order, as long as you're consistent and you remember where you put it, so that when you call the function, you give it the same order. And what are we going to do with this output file name variable? Well, as you can imagine, it's going to be a string. It's going to contain the name of the file that we want to save our output to. And what we're going to do is simply pass it as from inputting from the input of our outer function to the input of our inner function. So it's not used in any of the code for loading the data file. All we're going to do is add it as another input to our print gene expression function. So remember, there's the outer function, print gene expression from file, and there's the inner function, the actual print gene expression, which checks for the thresholds. The print gene expression from file function is simply file handling to load the data in from the file and create the data structures ready for the inner function to work. So let's follow this output file name variable that we've added. It goes from the outer function to be an input to the print gene expression function, which means we then need to add the output file name as an input to our print gene expression function. You'll notice it's the last argument here, because it was the last argument I gave here. The order is important. You know, that's how it knows which argument is which. So the output file name variable has been passed in here. And then what are we going to do with it? Well, we're going to adapt our print gene expression function such that a file is opened and our print statements no longer print to the screen, but they print to that file instead. So output file name here is going to be used in our fopen command. That fopen command looks like the one I showed just now. We have fopen, the output file name variable, which is going to be some string. It might say output.txt or c:\my documents, my output.txt, whatever it says. We're going to fopen the output file name, and then the W means that we need write permissions because we want to write some data to that file. And we're going to store an FID, a file identifier, as the result of opening that file. The rest of the code looks very much the same. The only thing we're changing is that in the fprintf line, which previously printed this gene's value is over the threshold, now is printing to that file instead. So before we have any quotes, before we have the string, we have this FID that we just created using file open. So now our print statement says print to the file some string, comma, some number, new line. And that format's pretty specific to be able to be recognized by things like Excel. It's a standard CSV file format. So you'll need to get used to writing things in this way if you want them to be accessible from other bits of software. You're probably going to separate your strings, separate your columns with commas, and then have new lines at the end of each row. If you open any CSV file, it will have a similar format to this. One thing to be aware of, if you are working on a Windows machine and you look at the file and find out that everything is still on one line despite the new line character, it may be because the new line character in Windows is actually different to Mac and different to OS X, different to Linux. Rather than a \n on Windows, you may need to use \r\n. So this is Win, and this is all of the Unix-based things, including the Mac. So you can try it without, and you might find that Excel is perfectly happy with opening other file formats. But if you come across a problem, you might want to put a \r\n there rather than just a single \n. Okay, so the rest of the code looks the same. The only extra thing we've added is this fclose FID, which will close out the file given by the file ID. So the file we opened will then be closed, ready to be checked in other bits of software, ready to do whatever we want with. So we run this file we run this function the same way we've been running it until now, but we have one extra input. So we're going to do print gene expression from file, and if we go back and look at what the print gene expression from file expects, it expects 4 inputs. It expects an input file name, an output file name, a gene of interest name, and a threshold. And we give them all here. An input file name, an output file name, a gene of interest, and a threshold. And we give them in the same order. So when you run that, what you should see printed to the screen is still that the experiment 1 loaded however many genes it loaded, because we left that fprintf statement the same. It should still print using this awkward concatenation line that the expression of CCL5 is over of our gene of interest is a certain value. But what's really interesting is that it will also create an experiment output.txt file in the working directory, or whatever name you gave it here, and you should be able to open that in Excel or in another spreadsheet manager software and see that all the genes over your threshold are now saved as a table in ready to be opened there.
Why wasn't that space converted to the CCL5?
Oh, it's this problem with this stupid strcat command. Again, something I showed you just because some people use it as a trick, and it's going to strip out various spaces. strcat does this. So it would be better to replace the whole line with an fprintf with 2 substitutions rather than trying to concatenate a variable in there. Purely because of this problem. Sure. So the only real